This conference will now be recorded.
Wait a second. Yeah. Okay, right. Good afternoon, everyone. So, is my screen is visible to everyone, guys?
Yes, sir.
Yes,
Okay.
sir.
Will we start?
Visible, sir.
Okay, then yeah. Uh, so, good afternoon, everyone. So, welcome to the second lecture of prestressed concrete structures. So, just I will try to revise the things which we discussed in the previous class. So, yesterday we gone through what exactly the prestressed concrete structures and how it is different from RCC structures, and what are the prerequisites of prestressed concrete structures in terms of the subjects which you learned in the previous semesters, like concrete technology, right? Design of reinforced concrete structures. So I hope you people please go through the subject like concrete technology and DRCS. So before you come to the PSCs, research concrete, right? So because they are very important for you guys to refresh the fundamentals and basics of concrete and steel structures. Okay. So let's start the second lecture on PSC. Right. So today we are going to start with the module one. So the module one, which carries with the historical development of prestressed concrete structures of prestressing technology, and which is added with the general principles of prestressing. So which comes with the pre-tensioning and post-tensioning, and what are the advantages and limitations of prestressed concrete structures, and what are the materials to be used in prestressing technology, right? And so what exactly the high strength concrete and the high tensile steel and their characteristics. Okay, so these are the topics which was involved in module one. So first we will start with the historical development. Before that, so let's try to know what exactly about the pre-stressing, right? See, pre-stressing is one of the application, so where we try to invent some initial load on the structure, okay, before where the structure is under service condition. Okay, so before the service, what we do, we are going to implement some initial load on the structure. So why we are going to implement that initial load? To enable the structure to counteract the stresses arising during its service period. So let us take an example of simply supported beam. So when it is subjected to point load, you know what is the deflection carries by a simply supported beam. So what will be the deflection? It will be like WL cube by 48A, isn't it? So that is a deflection. See, in this pre-stressing technology, what we do, we will try to counteract the deflection in terms of applying pre-stressing forces into the member. So by that, what happens, instead of sagging, it will go to hogging with the same deflection of WL cube by 48 here. Understood? So that is what we are applying that pre-stressing into the concrete element or any beam or any structural element to counteract the stresses which is arising during the service load. So because of that service load, you may see the deflection of the beam. So that deflection, you are contracting the stresses with the help of this pre-stressing technology. Understand? So this is what the exact definition of the pre-stressing. And next, coming to so what is the difference between pre-stressing and pre-stressed concrete, right? So just now we gone through pre-stressing is an introduction of a compressive force. So here what we do when we are applying a tensile stresses to the strands, So what happening, you are going to apply the compression forces to the concrete, right? So when you come to college, definitely I will try to show you a live example how this that pre-stressing can be applied, where the steel rods in a concrete member is subjected to tension and concrete will be subjected to compression. Okay, so this is what happening in the pre-stressing technology. So here the introduction of compressive force to the concrete to counteract the stresses that will result from the applied force. Okay, so what do you mean pre-stressed concrete? So here it is also a form of concrete, so but it is used in construction, so with the help of this pre-stressing technology. Okay, so whereby being placed under compression prior to supporting any loads beyond its dead weight. Okay, so that is what exactly the pre-stressing concrete with the help of this pre-stressing technique. So here the compression which is going to be induced or produced into the concrete, so with the help of the tensioning of high strength tendons. Okay, so I think yesterday we have seen some images, so how you are pulling the strands, where the strands are subjected to tension and concrete will be subjected to compression. Okay, so here the compression is produced by the tensioning of high strength tendons, so which are located within the adjacent to the concrete volume. Okay, so in that concrete itself there will be a high strength tendons where you are going to pull those tendons, so where it will create compression to the concrete. Okay, then concrete will be packed, concrete will be subjected to huge compression force into it. Okay, so that is the reason why in this pre-stressing you are supposed to use high strength concrete to take care of high compression forces. So you have to use high strength steel to take care of high tensile forces. Okay, so these are the two important points we have to remember while you are going for pre-stressing technology. Okay, and let's see one example. What is exactly the principle of pre-stressed concrete? So here the best example where you can easily understand what exactly the pre-stressing technology means. So let me take one example here. The principle behind pre-stressing is applied. Let's take a row of books. Okay, so not just one book, just take a row of books of 5 to 6. So just keep them aside, right? So here the row of books is going to move from place to place, isn't it? So when you are not applying any compression forces towards the book, what happens? Every book will try to fall, right? Why? Because so they are going to move from place to place. So instead of stacking the books vertically and carrying them, so the books may be moved into horizontal position by applying pressure to the books at the end of the row, isn't it? So each book will have that that pressure where the books are supposed to be fall one on another, right? So here the pre-stressing concept comes into picture. So let's try to apply a pressure on either side of the book stack, on the left hand side and right hand side of the book stack. So when sufficient pressure is applied, okay, so nothing but compression stresses, so which are going to be induced or introduced into this book stack, so the entire row and the whole row can be lifted and carried horizontally once, isn't it? Right? See, without applying the compression force, you can't lift the whole stack at once, right? So here what happens when you try to apply this sufficient pressure on either side of the book stack? So if you try to lift it up, you can lift the whole stack of the books. How you are lifting? So you are applying force on only two ends of the books, but not in the center. But what happens when you are applying this compression stresses on either side of the books? You are in a position to lift the whole stack of the book. Why? Because there is some compression stresses which are inducing throughout the entire row. So that is what exactly the pre-stressing concrete or pre-stressing technology which we are using in the structural elements, particularly like beams, girders, right? Even the slabs and all. So here also the same. So when you try to pull the strands in that instant, you are applying some compression forces in the beam. So by that the beam will try to lift it up. Okay, the beam will try to lift. So when it lifts, it goes into hogging, isn't it? Hogging is nothing but contraction of the sagging of the beam based on its loading condition, right? So this is what the principle of pre-stressing concrete or pre-stressing technology. Okay, I hope you all understand why this pre-stressing technology or pre-stressing concepts comes into picture in terms of understanding better of RCC and PSC, right? So next, what is the need of pre-stressing for concrete? So do the concrete alone can't able to carry the load? Do concrete alone, based on its compression strength, can't able to carry the working loads? No. So there is something need for the pre-stressing concrete. So let me talk about a few points how the concrete is needed with some pre-stressing technology. So here the concrete tensile strength is only 8 to 14% of its compression strength. See, so let us take 20 MPa of compression strength of a concrete cube. So if you calculate its tensile strength with the help of some flexural strength, so it will be only 8 to 14%. As we know, concrete is weak in tension. Concrete is weak in flexure, right? So this is the weakest point of the concrete, right? So for these flexural members like the beams, slabs, and footings and all, they're all flexural members. Beam is a small in depth, right? So beam slab will be in small in depth. It is also called as a short beam. So where the flexural members like beams and slabs, cracks develop at early stages of loading. Why? Because your concrete is having very weak towards its tension. So to prevent these cracks, what they do, the compression forces can be suitably going to applied in longitudinal direction, either concentrically or eccentrically, right? So this is what exactly called a linear pre-stressing. So here you are not applying this pre-stressing in lateral direction. You are going to apply it in longitudinal direction. Okay, longitudinal direction in the sense towards its length, right? So the one more thing, pre-stressing contracts the tensile stresses, and it's going to reduce the chances of formation of cracks. Okay, so as we know, concrete is weak in tension. With the help of this pre-stressing concepts of pre-stressing technology, the concrete can reduces the chance of formation of cracks. Okay, and one more thing, the pre-stressing enhances not only bending but also shear and also torsional capacities. Okay, so in terms of its flexural members, right? So this is the way how the pre-stressing enhances bending, shear, torsion with the help of this technique. And in cylindrical tanks, let's take an example. The hoop tensile stresses can be contracted by circular pre-stressing. Okay, so not only in a longitudinal members, even in a circular tanks, the pre-stressing technology can also be used, where the pre-stressing are going to be applied with the contraction of the hoop tensile stresses. I think you already gone through thick cylinders and thin cylinders in strength of materials too, right? So what are the stresses acting in a cylinder? There will be a hoop stress. Hoop stress is nothing but what? Circumferential stress, which acts within the circumference of the cylinder, and there will be a longitudinal stress, isn't it? So let's talk about the hoop stress, hoop tensile stress, which makes your cylinder having a tensile stresses into it, right? So that tensile stresses can also be contracted by applying a circular pre-stressing into the cylindrical tanks. Okay, not only a beams, even you can do the pre-stressing for circular shapes or circular structural elements. Okay, so this is the need of R for pre-stressing for this, pre-stressing technology. Okay, so let's talk about the necessity of high grade concrete and steel. So why can't we go with the normal grade concrete, sir? Why can't we go with the normal grade of steel? Why high grade concrete and high grade steel is necessity, right? Necessary for that. So as I already told you, when you are try to pull the stands, it should have a capacity to lift the concrete up, right? So that can't be happen with just a mild steel rod. You need to go with high yield strength deformed bars to apply a tensile force into the steel rod. At the same time, when you are pulling the strands, it will compress the concrete. So when it is compressing the concrete, as we know, concrete is a brittle material, but still it will have some elastic nature, right? It will try to hog. Okay, so concrete will bend, right? Isn't it? So till some extent, till its elastic zone, concrete will try to hog. Okay, so when it is trying to hog, so definitely concrete should have a high strength. Okay, so the high grade of concrete is higher the bond strength, so which is vital in pre-tensioned concrete. So not only based on its compression strength, when you go with high grade concrete, obviously the concrete will have high bond strength. So that is the reason why you have to go with the high grade concretes like M35, M40, M50 like that. Okay. so which is going to be vital in pre-tensioning concrete. And also higher bearing strength is vital in post-tensioned concrete. So in pre-tensioned concrete, bond strength is important, and in the post-tensioned concrete, bearing strength is important. Okay, so by keeping these 2 points as an important one, so you're going with high grade concrete in pre-stressing technology. So further, not only that, creep and shrinkage losses are going to be minimum in high grade concrete. I will let you know what do you mean creep and what do you mean shrinkage. So these are the losses in pre-stressing concepts. So creep and shrinkage. So to reduce the creep and shrinkage in concrete, you can go with a high strength concrete. Okay. So these are the advantages of making use of high strength, high grade concrete in pre-stressing technology. So generally, minimum M30 grade concrete is used for post tensioning, and M40 grade concrete is used for pre-tensioning. Please try to remember, guys. So beyond M30 grade, we can conclude it as a high strength concrete, because if you see IS 456 2000, so there will be mixed design specified till M25 grade, isn't it? So we can consider these concretes as a normal strength concretes, like high strength concrete in the sense it is beyond M30 grade, like 30 MPa. Okay. So minimum M30 grade is going to be used for post tensioning, and M40 grade is used for pre-tension. So in the next coming classes, I will give a brief introduction, a difference between pre-tensioning and post-tensioning also. Okay, no worries. So pre-tensioning is nothing but before casting concrete. So when you are applying tensile stresses into the strands, so that comes under the post pre-tensioning, and post-tensioning is nothing but after concrete sets, okay, and attaining its attaining its 28 days of characteristic strength. So then you are going to apply the tensioning into the tensioning of the strands. Okay, so that is what the post-tensioning and pre-tensioning of the members takes place. So please try to remember the grade of concretes are going to be used for pre-tensioning and post-tensioning. And finally, what is the necessity of using high grade steel? So till now we've gone through necessity of high grade concrete. Then coming to steel, high tensile steel weights are going to be used, so which can carry from 1600 to 2000 Newton per mm square to reduce losses in pre-stress members. Okay, so that is the biggest advantage of making use of high strength steel instead of a normal mild steel rods, right? So these are the necessities of using high grade concrete and steel. So let's go to the history of pre-stressed concrete, okay, or pre-stressed technology. So the first pre-stressed concrete, so which was appeared in 1888. So when P.H. Jackson was granted the first patent in United States for pre-stressed concrete design, right? So here the what is the main idea of Jackson? So here Jackson idea was perfect. So he introduced the technology of high strength steel, so which was exhibited low relaxation characteristics, so was not yet available. So at that time, so he tried to make use of this high strength steel, so where it can able to carry the maximum tensile stresses and where it can able to lift the concrete towards its hogging nature. Okay, so that's the main what I can say, the experimental work or design work which was carried in prestressed concrete design at that earlier stages of 1888. And it was not until Prestressed, so who is going to define the need of these materials, so which is that prestressed concrete could be used as a structural building material. So then after, so I think there is a method called a Prestressed design method also, how to design the prestressed concrete with the help of Prestressed method. So here he tried to make use of by applying these tensile stresses into tensile stresses of high strength steel. It can be used in prestressed concrete where it can be used as a structural building material also. Okay, so he introduced that where this technology can be used in even the structural building material. So unfortunately, although the Prestressed, he's a structural engineer, from French, okay, from France, and not only a structural, he is also a bridge builder. So he lacked the teaching qualities necessary to communicate his ideas to other engineers. Okay, so he couldn't able to deliver what exactly the prestressed concrete. I mean, so prestressing technology can be used in building construction materials. So where it can be used to carry the heavy loads. Okay, so he couldn't able to convey properly. By that, there are a lot of methods came into existence after this Prestressed method. Okay, these all methods are which we are going to study in the second module, right? So this is a brief history. Apart from that, how this prestressing technology were used in olden days in some other applications. So here the application of prestressing in concrete structures is not only an incident. So earlier they used this prestressing concepts in other applications, like fitting of metal bands or metal bands on wooden barrels. Okay, see, there you can see how the wooden barrels were banded with the metal. Okay, so where it can be used as a for stacking wines or some kind of liquid into it. So here there are two examples where I would like to show you. One is fitting of metal bands on wooden barrels, and the next one is rim with the pedestal. Okay, so let me explain these two. These are the applications where this prestressing technology was there from olden days. So here you see how this prestressing technology were used in wooden barrels. So here the metal band, you can see the metal band over here. So this is the metal band, so which is fitted around the barrel to its circumference to ensure the state of initial hoop compression, right, isn't it? To counteract the hoop tension caused by filling of liquid in the barrels. See, if you try to fill the barrel completely with some liquid, what happens? It will develop the hoop stress towards the circumference of the barrel, right? So how to avoid the failure of the barrel towards its hook towards its circumference? We have to fit this barrel with some metal bands where it can able to counteract the same stress which was induced from inside, isn't it? So I have to apply, or I have to fit the wooden barrel with some metal band, so where it can counteract the stress which is developing from the internal internal fluid. Understand? So this is how the wooden barrels were fitted earlier with some metal bands. Okay, so I think in the design of steel structures we already gone through one example, how the bullock cart wheel was stripped with some metal metal steel strip, right? So the same kind of here there the temperature and hoop stresses comes into picture. Here some kind of pre-stressing technology comes into picture, so where it is going to be induced or filling, I mean, to safeguard the wooden barrel towards the hoop stress developed from inside liquid. Okay, so the next one is pre-tensioning of spokes in a bicycle wheel. See how you came to know that the spokes are fitted exactly straight without any deflection, okay, into the wheel, into the bicycle wheel. So here also pre-stressing or pre-tensioning comes into picture. Here the pre-tension is applied into the spoke to such an extent that there will always be a residual tension in the spoke. Understand? See, when the wheel try to rotate, so what happens? The weight will fall towards its centroid axis, isn't it? So that load is going to be carried by each spoke. So spokes should try to deflect or will bend, isn't it? So when it is subjected to load, so why it is not bending? So why? Because the members are pre-tensioned before fitting that into the wheel, into the rim. Okay, that wheel we call it as the rim. So here the pre-tensioning of spokes in a bicycle wheel was introduced, so where it can able to carry the tensile stresses. Okay, so these are the best examples where in olden days this pre-stressing or pre-stressing and the stress in terms of tension, the stress in terms of compression. That is that is the meaning of pre-tension. Okay, so that is how the pre-tensioning of wooden barrels with the help of steel strips were made, and the pre-tensioning of spokes in bicycle wheel was done in the earlier applications. Okay, so now in recent days, this pre-stressing technology is came into our building structural elements, right? Yeah, and one more point here is the concept of prestressed concrete is also not new. So as I already told you, like Prestressed was introduced in the year 1888. So it was got patented that prestressing concrete structures was designed from the year 1888. So it was patented and it was granted for tightening steel tie rods in concrete blocks, and it was there from early days. And here the early attempts were not very successful. Why? Because due to low strength of steel at the time, there is no point of having this high strength steels into picture. So that is the reason why it is not that successful at world in this. But nowadays there are different types of composite materials available, where we can make the steel into high strength steel rods. So here we cannot pre-stress at high stress level. So there is a limit. So we have to go through the pre-stressing losses, which is developed due to creep and shrinkage of concrete. So which is going to be quickly reduce the effectiveness of pre-stressing. So you can't apply the pre-stressing of strands, stressing of strands as require. You can go with as per the requirement. So based on the pre-stressing losses, uh, considering the pre-stressing losses in terms of concrete and in terms of steel as well. Okay, so this is how the um, history of pre-stressing technology there in the olden applications, right? So let's discuss about two important concepts over here in this pre-stressing um, technology. So the two important materials which we are using over here, one is concrete and the other one is steel. So concrete in the sense high grade concrete, and steel and high grade steel, right? So let's talk about the concrete. So where the concrete, we all know it is also a composite material. One, it's a composite material, so which is a combination of cement, aggregate, or coarse and fine aggregate, and even the water. So this is how the concrete is a composite material. So let's talking about the mechanical properties of concrete, which is very relevant to the prestressed concrete design. So here we should bother about the compression strength of the concrete and modulus of elasticity, so which is an Young's modulus, and modulus of rupture, right? So these three are very important mechanical properties which we have to consider when we are using high strength concrete, high grade of concrete, which is very relevant to the prestressed concrete design, right? And the next one, the other properties of concrete, so which one should be very familiar before attempting or making use of this concrete in pre-stressing or pre-stressing design. Okay, so that is the reason why, as I already told you in the day one, so the prerequisites of pre-stressed concrete is, one is the concrete technology, other one is DRCS. So please go through all the mechanical properties of concrete. So by this, these are going to be very important in designing the pre-stressed concrete, you know, in structural applications. So these are the very important properties. One is compression strength. The other one is character of stress strain relationships, and modulus of elasticity, creep and shrinkage, and tensile strength or the flexible strength. Okay. So these five properties you people should try to know before designing this prestressed concrete elements. Okay, so let's go into deep with some information. What do you mean compression strength of concrete? So here we all know the compression strength of concrete is nothing but the characteristic compression strength of a cube, of a sized cube, for 150 by 150 by 150. So it's a normal size of the concrete cube, so which is going to be tested at 28 days of its curing, right? So here the character strength is going to be defined as the strength of the concrete, as we know. So which should not more than 5% of the test results which are expected to fall, right? So let us take M20 grade of concrete. So the characteristic compression strength of the concrete is to be 20 MPa, right? So it should not more than 5% of the test results. So where it's supposed to be, because when you test it practically, you won't get exactly 90. Okay, it will be somewhat in between 20 to 26, which we call as a target mean strength. Okay, I think you all know how to calculate the target mean strength of any of a grade of concrete, isn't it? So it will be in that range when you start calculating its compression strength with the help of compression testing method. So here this concept is going to be assumes normal distribution of strengths of all the samples of concrete which you take, either in cube or either with respect to cylindrical shape. Okay, so that you already know, and I think in the fourth year you are having concrete technology and highway materials lab, so where you can start designing the concrete and of your own grade, and you can test it for its compression strength. Okay, And the next one is stress-strain relationships. So this also we will try to make you understand better while discussing the design of concrete. At the same way, how the stress-strain relationships there for a different grades of concrete and different brittle materials available, right? And the next point is which are the very important points to recall about the reinforced concrete. So here, as we know, concrete is very strong in compression and it's bit weak in tension. So steel is going to be strong in tension, so as well as compression. So here the reinforced concrete uses concrete to resist the compression, and it is going to be hold the steel bars in place. So that is the reason why we use reinforced concrete, okay, to resist all of the tensile forces which are used in the element. And the tensile strength of concrete is going to be neglected. So why? Because it won't have that carrying capacity. So by that we can consider it as a zero. And the reinforced beam, which is always crack under service load. So that is the reason why we are you know going to be considered, and we are going to design these prestressed elements in terms of you know limit status. And what are the defects in concrete, as we mentioned in the previous slides? So these are the two important parameters which we have to consider as a losses in the concrete. Like one is shrinkage, the other one is the creep. So here, which is shrinkage is nothing but which is associated in the loss of moisture, right? So we all know shrinkage is nothing but loss of moisture from gel properties of the paste, like a cement paste. Okay, so when you go with high grade of concrete, definitely you can have very less shrinkage. Okay, so that is the reason why we are making use of high grade concretes in prestressing, technology. And coming to creep, so creep we all know it's a time dependent one. So when the time goes on, because the creep is a durable property, so it's a time dependent one. Time dependent, so it increases in deformation with a sustainable load. So it's if this creep is well known in even in RCC structures, right? So we always calculate the deflection of any member with its self weight, okay, not with its factor load. So as we know, so in the same way, so creep is a time dependent one. It's a long term deflection, we can call it as. So which is due to a sustained loading or nothing but it's a constant loading, which is going to occur in all types of loading in terms of compression, in terms of tension, and in terms of torsion, right? So earlier the age at which loading is applied larger than the creep, so where the creep is higher in wet conditions than in dry conditions. So because in wet conditions there is a possibility of more deformation in the member due to its constant loading. So in that way, these two defects are very, very important. We have to consider these as the major parameters. So that's the reason why we are going to use the high grade concretes to avoid the shrinkage and creep in the concrete, okay, particularly in this prestressing technology. And next, coming to structural steel, I mean different types of steels available, and the material which we're going to use in the prestressing technology. The term commonly used in prestressing concrete are explained so in the previous slides. And what are the different types of prestressing steels available? So one is the wire. It's because now there are different strands available where twisting them in the form of I mean the plies which are twisting them into a form of a strand. So earlier instead of having a strand, earlier they used to use wires for pre-stressing wires in a form of a single unit which is made up of exactly the steel. So there are steel wires available. Now we are having strands. Strand in the sense 2, 3, or 7 wires are wound to be form of a pre-stressing strand. Okay, so this is what is strand. Earlier, it's a single wire. So when you wound all the wires, so it's going to become a strand. So there is specific wires to be wounded into a strand like 2, 3, 7, 9 like that. So you can't even 5 also. There 5 strand. I mean 5 wide strands will be there. So like that, there will be specific wires is supposed to be wounded into a strand. And next one is tendon. A group of strands or wires are wound to form a prestressing tendon. So you have to know the difference between a wire, strand, and a tendon. Okay, wire is an individual member. So when you wound wires, it's going to become a strand. So a group of strands are going to become a tendon, right? So next one is cable. So here we use a group of tendons form a prestressing cable, right? So it's an add-on once. So you have to understand one by one: wire, strand, tendon, and finally the cable. A group of tendons forms a prestressing cable. So majorly these cables are used for cable stay suspension because so their bunch of tendons are made it into a cable, and where they are supposed to be used for carrying the tensile forces. And finally, bar. I think we all know the bars which are used for rebarring, in RCC structures. So a tendon can be made up of a single steel bar. So the diameter of the bar is much larger than that of a wire. So here you can make all tendons into a single steel bar also. So which is having some threaded part on its surface. So where it can be used as a single rod, so which the diameter will be more than a normal wire. So these are the different types of steels available, so which we are making use them for prestressing funds or prestressing technique. Okay, so that's it, guys. So these are the topics which I thought to discuss in the today's session, right? So if you have any doubts, so you can express it. So 18 is the strength now. Guys, any doubts? So you can unmute yourself and you can ask the question. Which one? Industry, Gopi, Lavanya, Mohan, you can unmute yourself and you can ask doubts if you have.
Sir,
Yeah, who is this?
no sir, no doubts.
No doubts. So please
Yes,
try to question yourself like in any doubts you can express. Again, don't feel to ask many students or or else it's your question. Anyone? Rahul, Srinija, Vamshi, Bharatwa, Harini, Anusha. No doubts. So tomorrow we'll try to focus on what are the topics in the first module. Yeah. So the general principles of pre-stressing, right? Like difference between pre-tensioning and post-tensioning. We'll try to discuss them and the advantages and limitations of pre-stressing concrete. So we'll try to cover these two topics the tomorrow session, right? And we'll try to spend much time on materials. I will try to show you all materials which were used for pre-stressing.
Sir,
Yeah.
is this concept applicable for cantilever structures, sir, in buildings or
Yeah,
bridges?
exactly. See, for all infrastructure projects nowadays, they are going for pre-tensioning along with the post-tensioning, right? So for especially for the pre-casted elements. So even for cantilever also, this pre-stressing technology can be used.
Where they will provide, sir, tendons above the neutral axis?
I
Or
think you have seen L&T Metro, right? I will tell you one best example in L&T Metro. So where the platform, right? L&T Metro, you have seen a center pillar, right?
Yes,
Adjacent to
sir.
that pillar, there is a platform. So that platform itself is a cantilever, right? And that cantilever were post tension. Have you seen that platform? L&T Metro lo meer ekkinappudu. So I think you would have standed on the platform, right? So that platform itself is a cantilever. Suppose on the other side of the cantilever, మీరు కింద నుంచి వెళ్తున్నారు కదా మెట్రో కింద నుంచి.
Yes, sir.
So it's completely a cantilever, isn't it? So that
Yes, sir.
cantilever was post tension.
Okay, sir.
Yeah. So whenever you go now try to observe. You can see that stressing the portion on ends of that cantilever portion. We'll observe I will try to show you some pictures, okay, where you can able to understand how the cantilevers can be, force tension.
Okay, sir.
So what else? Anyone?
Okay, sir.
See, nowadays even piles are also undergoing, pre-stressing piles. So I think you all know piles, right? Deep foundations, right? So pile is a deep foundation. So nowadays piles are also going with the pre-stressing technology. Not only piles, columns are also going with the pre-stressing, right? So earlier they used to go with only a longitudinal members like slabs, beams, and foundations. But nowadays even they are going for vertical members like columns and piles. So they are also going for pre-stressing nowadays. Okay. Right. Anyone? Any doubts? No. Still 10 minutes left. Text message. Yeah, so compression pressure ఎంత ఉండాలి సార్? The compression pressure, see, in design we'll come to know. So what is the tensile stresses which we are using to the strands? So that all will come to know in the design. Okay. So based on that, your concrete will be subjected to compression and it will try to lift it to the top. Okay. So that's how we will know how much pressure you are going to apply. That everything will come to know in the design while pulling the cable, tensioning of cables, mean tension pressure. Okay. Use this concept applicable can be also, yes, it's applicable. No doubts. So anything else? Guys, so Mithun and Harini, please try to request other students try to install this GoToMeeting. Okay, because in this session it's around 18 students attended. I think in the previous first 3 classes the strength is around 25, 26. So maybe due to new app they couldn't able to come to my session. So please request them to install GoToMeeting, so by that they can have my classes. And one more thing, immediately after completion of this session, I'm sharing this PPT to WhatsApp. At the same time, I'm sharing this recorded video to your mails and to your WhatsApp group. Okay, by that you can just go through again, and any doubts you can just ask me through WhatsApp. Okay. Currently, you also please take initiation, and because you're from your class the strength is only 30%. Okay, we are expecting 100% from each section. Okay, so Mithun and Harini, please take initiation in attending the 100% attendance from your section particularly.
Yes, sir.
Okay. What else?
Sir, screenshot చేసుకున్నారు attendance.
No need, because in GoToMeeting, I'm getting the whole list.
Okay, sir.
Students list మొత్తం వస్తుంది నాకు. I will try to record that.
Okay, sir.
Even whatever you're chatting, so that is also getting saved in GoToMeeting. Right? So can I close the session? Any doubts?
No, sir.
No? Okay, then, yeah. So see you tomorrow, okay, as per the timetable, right? Okay. So thank you, and